Hello boys and girls and welcome. So I said that I would do some examples for you to finish off. These are factoring examples, and so I'm going to start from the beginning again so that you have a complete set of notes, and I'll probably do the first three and then we'll do the second three in a second video. Alright, so let's get started. So this is a trinomial. You know it's a trinomial because there's three terms. What you want to do is you want to be able to factor this. I've got an x squared and an x and a common term, and a numerical term, and there's nothing in common in the three terms that I can factor out, but you always try to do common factoring first. The next thing you notice is that it's a trinomial, so I'm going to try to use seesaw. So seesaw, we know the final answer is going to look something like this. Now, we put a 3x here and a 3x trying to get a 3x squared. Notice that if I multiply 3x by 3x, I get 9x squared. There's a multiple of 3 too much here. So, you put a 3 on the bottom. That's how you set up for a seesaw question. Now, you're looking for two numbers that multiply to give 6. So, using the factor tree, 1 and 6, 2 and 3, 3 and 2. If it's going to factor, it's going to either be these two or these two. I try to put them together in some way to be able to get 7. 2 and 3 can't go together to get 7. 6 and 1, though, they can. It doesn't matter if I put the 6 here or the 1 there, it just doesn't matter. Now, for the sign, I do it probably a little different than you've seen before. To be able to get positive 6, then it must have been two positives being multiplied together or two negatives being multiplied together. That's the only way we're going to get a positive 6. Well, they're going to add together to give me a positive, so they must both be positive. If they're both negative, then they'd add to give me a negative 7, and that wouldn't work. This 3 on the bottom will common factor, it will reduce, so it's either going to come out of this one, or a bit of both. So it's going to be 3x plus 1, common factor of 3 out of this, x plus 2 over top of 3. So I've got this times this times this divided by this. So these two can reduce. And that's going to leave us with 3x plus 1, x plus 2. Check it out. 3x times x is 3x squared. 3x times 2 is 2x, plus 1x is 7x, plus 2. It works. I'm good to go. Over to the next one. Okay, taking a look at them. I try to common factor. There's nothing common that'll come out of all three of them. It's a trinomial. So I know the answer is going to look like a 1x and a 1x. Now if I want to do this using seesaw, you simply think about having a 1 here and a 1 here all over top of 1. But you don't have to, as you learned in grade 10, but if I do it this way, it'll work out. I'm looking for two numbers that multiply to give 1 times 21. So it's either going to be 1 and 21, 3 and 7, 7 and 3. So if it factors, it's going to be either this pair or this pair. I need a pair that'll go together to give me 4. So I'm thinking the 3 and the 7. Now, they multiply to give me a negative. So it's negative 21. So if they multiply to give a negative, one's positive, one's negative. They add to give a positive. So when I put the two together, I have positives left over. So the larger one better be positive. 7 subtract 3 is positive 4. Notice the 1, the 1, the 1. I don't really need them. So you did use seesaw, but you can save yourself some steps. Check it. X times x is x squared. 7x minus 3x is 4x minus 21. Excellent. Okay, so now we're down to here. Look to do some common factoring. There is no common factoring that'll work. So I'm looking for two numbers that'll multiply to give 30. But before I do that, I set up my seesaw. Remember, it's got to have the 5 on the bottom. If it doesn't have the 5 on the bottom, it's just two dumb kids sitting on a piece of wood. So I'm looking for two numbers that multiply to give 30. There's a few of them, 1 and 30, 2 and 15, 3 and 10, 4 doesn't go evenly, 5 and 6. After that, it'll double over. So I'm looking for any of them that'll go together to give 13. Well, there's two of them. That'll give me 13, and that'll give me 13. So there's two possibilities. They need to go together so that one's positive and the other one's negative. So one's got to be positive, one's got to be negative. The only way 3 and 10 go together to give me negative 13 is if they're both negative. so it's not that one. So it's going to be 15, and it's going to be 2, and one's positive, one's negative. They go together to give me negatives, so the larger one must be negative, because negative 15 plus 2 is negative 13. This is going to reduce out either from here, or a bit of both. You'll notice at the top, this times this times this divided by this, they can reduce, leaving us with check it. 5m times m is 5m squared. Minus m times 2 is positive 2m. Minus 15m is negative 13, negative 6. It works. Yay. Okay, over to number 4. Taking a look at that, I'm going to common factor out a negative because I don't like the negatives in front, and the whole thing has a value of 2, I think, that can come out. So it's going to be negative 2, and it's going to be 5x squared minus 14x plus 3. So now we want to see if we can factor this any farther. So you're looking for two numbers that'll multiply to give 15. So it could be 1 and 15, 2 doesn't go evenly, 3 and 5, 5 and 3. And they have to go together to give negative 14. Well, 1 and 5 looks like it might work. So let's think about that. They have to go together to give a positive. So they're either both positive or they're both negative. They have to add to give negative 14. Well, there's no way that if they're both positive I can get 14. There's no way if they're both negative I'm going to get negative 14. So this does not factor. What that means is you're going to write it as minus 2, 5x squared minus 4x plus 3, and you're going to say does not factor. And that's important. It's important to be able to factor ones that do factor, and it's just as important to be able to know which ones don't factor. All right, I'll come back with another video in 2 seconds.